Hello, everyone. Welcome back. Now that we are getting deeper into, intro to computers, intro to computer science, the first thing we need to visit is just the overall topic of networking and what's involved in that. Um, I'm not going to get too deep and too detailed because truly networking can take a semester or more to fully understand. So, we're just going to basically cover the things that you need to know to get a brief understanding about what networks are and how they connect to the internet. And then that will allow you to just understand how technology as a whole works. So, let's go ahead and get started. So, how exactly does the data travel from one computer to another or even across the globe? So, when I'm mentioning data and I say computer, that also goes for how does data go from one phone to another. So, as you all know, we all use computers, we all use phones. We have no idea how our texts are being sent, we just know they're being sent. So, we're basically going to look to understand how that is. So, first, a network. That's very important for us to know because without a network, most of this would not work. So, a network is just connected groups of different devices. So, that can be computers, phones, tablets, basically anything technical is connected to it, right? So, it basically just allows devices to talk to each other, the network. So the network allows your devices to talk to each other or pass information or even access the internet. So your Wi-Fi, the school Wi-Fi, and the internet itself is actually considered a network. So basically, I just want you to think of a network like a road system, and basically, the cars on the road would be the data going from one place to another, which would be the devices. So, when you're driving on the interstate, just think of that as data, and all this data is going to different places. All the cars on the interstate do not go to the same place, they have different destinations. So, that's basically how a network visually kind of looks. So, we need to understand why it all matters, right? So, the first portion is that you need it for communication. Without having a network, you couldn't communicate with people without personally seeing them. The internet, like I said, is a network. And the internet allows us to share resources and collaborate with each other. So, if we did not have networks in place, we would not be able to do any of these things. So, we're going to look at some of the basic network components. And basically, what you need to know is that there are three main types of components within a network. Now, there are different types of networks, and different types of networks are set up depending on how they were, created by the end users. But overall, most networks are going to have your end devices, intermediary devices, and network media. So we'll deep dive into each of those. So, first, you have your end device. And your end device is basically the devices that you use, the devices you know. So that's your laptops, your tablets, smartphones, anything that you know, like even gaming stuff could be technically an end device. So it's just basically where your data is going to start or end. So this is the place where data is passing to or from. And then you have your intermediary devices. So that's going to basically be the devices that actually connect your end devices and they're controlling your data flow. So, in the case of many users, such as yourself, this would be the portions that allow you to connect to the internet from your home. So, you may know routers or modems, and you've heard it with your cable companies, or you've heard it just from maybe online or other tech classes, but they are two different things. So your router is the one that actually is directing traffic. So it's like the traffic guard between your network at home and basically the internet. And it basically gives you an IP address so that you can find, the other devices on your network and so forth. Whereas your modem is the one that actually is going to be connecting to your internet from your internet service provider. And this is just the one that would connect to your cable cord. And it's basically just converting digital signals from your computer into the analog signals for the cable or the fiber line. So it depends on what you have at your home. But it's typically a cable or a fiber line. So, for example, when you need Wi Fi, you need to be connected some way, shape, or form to your internet service provider via a modem. And then we also have intermediary devices, excuse me, and they basically are used to, of course, connect the end devices, which is just a continuation of the last screen. And as I mentioned prior, right, your network is created depending on how you create your network and or how that company decides to create their network. So typically, will they have most of these components? Yes. Not so much in the case of a home, like it just depends on your preference, but most of these are typically in them. So you have a switch and a wireless access point, as well as the router and the modem that we already covered. So your switch is just a device that allows you to connect multiple devices within a network together. And it basically just figures out, who the intended recipient is of the data. So it's kind of similar to your router, but more so it's just trying to figure out the actual ports that are connected and what it needs to do with those ports. And then you have your wireless access point, which is exactly how it sounds. It's just allowing devices to connect to a wired network wirelessly. So, as everyone should know, everything nowadays is mainly wireless, or at least that's the hope, because it's a lot simpler to work with than, hard wiring. And again, how are these connected? Through network media. So that would be the copper cables of, cable lines, your fiber optic cables, or radio waves for your Wi-Fi. So all of these components that I just covered are basically how the internet connects together. So your first keyword would be internet. So internet is the first keyword. All right, let's keep going. So we're getting into the types of networks, okay? So, of course, there are networks everywhere, but not all networks are the same. So we're going to cover the basic types of networks, but we are not necessarily going to go into how they are laid out, because again, networking in itself can be months worth of a class. So we're going to briefly just share the common types of networks. So first, we're going to introduce a PAN. So that's a personal area network. And so this is just basically like a small network that you connect your devices to in a small range. So this is basically revolving around you personally, hence personal area network. And these devices are typically connected through a USB or a Bluetooth. So, for example, your phone is typically connected to a wireless headphone or a headphone that you plug in. That, in a sense, is basically a network because you're passing your music data from your phone to the headphones that you're listening to. Same with your smartwatches. If you have Apple Watch, if you have Fit, then that's how your data is being sent via your exercise. Same with laptops and Bluetooth printers. So just think of it like that, how data is being sent between your personal devices. And then let's get into what that looks like, right? So technically, you may connect all of these items to, your laptop. And it's basically all revolves around you. This is not saying that the devices are connecting to another person, because let's say you hand your phone to another person and they connect it to their computer, that would be within their PAN network, not yours. So again, a personal area network is just basically typically around the individual and their devices. So now we'll get into a LAN. So a LAN is typically your bigger network, and this is like what you have in your home, because think about it, many homes have more than one person in it. So basically, LANs have, um, you know, a bunch of mini PANs within them. So your network for your LAN is basically just connecting your computers and devices in a limited area. So that's a home, a school, an office. So it's typically your smaller schools or offices that will use this setup. But yeah, smaller areas typically for LANs. And they just basically connect the device through Ethernet or Wi-Fi, but for most cases, it's generally Wi-Fi. Ethernet cables are typically used more so in the office area, and it could still be used in homes, but more so office areas currently. And the types of devices you can have, of course, are your laptops, some game consoles, desktops, etc. So basically, any technology device that you would need to connect to the internet or connect to pass data to and from. So this is what that would look like in a sense. Of course, on the left, you see all these different types of devices. So there's the router that we mentioned before, right? The router is what's directing the traffic of your home internet. And then basically the device is going to hit the router, and then the router's information gets sent to the modem, and the modem pretty much tells, you know, the next step. So, what do you need to do to get to the internet from that point? So, this is how a typical LAN is set up. However, is it just singular devices? No, you could have millions of desktops connected. Well, not millions, but you know what I mean. You can have more than one desktop PC connected. You have more than one TV. And just think about it like in a household. How many gaming consoles are in a household? How many smart TVs are in your household, etc. So there's not necessarily a limit to the amount that connects to the router. However, the more devices on the router requesting information, the slower your internet service is. So sometimes that can be the cause of slow internet. So, in the case where you have to go over a wide range, so this is like, across the world, that would be a wide area network or a WAN. So, that's just when you need to connect multiple LANs together. So, this would be in the case of various companies and various business, right? There's an Apple store in every location you can think of. They all use the same network. However, they basically have networks spread across the globe, right? So there may be a LAN system at this specific Apple store, and that Apple store has its own LAN store, and this one has its own. And they basically all connect together to create a wider network. So think of it as when you go to like a shoe store and they don't have the shoe you want, but they're like, hey, we can look in the system to see if another store has it. That would be a WAN. Technically, in that one store, they're connected to a LAN, but when they're saying we can look at another store's data, that means they're connecting to their company WAN to see if they have it in stock. So think of it like that. And the most common type of a WAN is the internet. That's basically what the internet is, to give you more insight into that. So that's what it will look like depicted. Of course, like I said, it can vary across the globe. So this is not necessarily a true accurate use case, but it's just giving you a quick depiction. So, the WAN can connect to your ISP or your internet service provider. So the whole city might be a WAN. A whole college campus could be a WAN, depending on how big it is. The government, enterprise companies, etc. So there are millions of WANs in the world. So Now that we kind of know the networking structure of how your data is actually utilized or how your devices are connected, now we're going to get into how the data travels. So, second keyword, data. Second keyword is data. All right. So, how does that data travel, right? We know how a network is, and I kept mentioning, yes, your data needs to travel over the network. So, for it to travel, your data is actually split into various different pieces called packets, okay? So, when you send an email, you may think the whole email is being sent, but that's not truly the case. It's actually broken up into many different pieces to travel across the network. But it basically is just making it easier to send because it's chopping it up. So these packets go across the network and then they get put back together before it gets to its destination or before it's viewed. So just think of it like you're mailing a puzzle piece in separate envelopes, and then you just open up the envelope and then it gets put back together. So it's kind of like that. And so, because the packets are sent, um, you need to understand where they're coming from. So this is where IP addresses come into play. And if you don't know what IP actually stands for, it's Internet Protocol. So technically, when you hear IP addresses, that's basically the same as an Internet Protocol address. And that's going to be just your unique label that is given to your device. And it basically is just telling you, hey, this is what the device is. Instead of saying, MacBook Pro connected or a MacBook or a Linux computer has connected, right? Millions of people have Linux, millions of people have a MacBook. So, how do you know exactly which one is coming from? That's why IP addresses are important. So it's like a digital street address. So like where is it originating from? So you may have heard of public versus private IPs, right? So public IP addresses are the ones that face the internet. So basically are assigned by your internet service providers. They can be seen by the internet. Your private IPs are the ones that are actually used within your home network or within a network, and they can't directly be seen from the internet. So there are two different types of IPs that you may see for your devices. And you may have also heard of MAC addresses. So, this is pretty much your ID for the actual device or infrastructure that is typically given from the manufacturer. So, the person who built that technology device, but it's basically just used for identification purposes of the actual device itself. And that's what makes it easier for, you know, if you take it to tech support, they might ask you for your MAC address because they know, okay, this is the device that we're talking about. So it's basically like a unique name for a device, I guess you could say, but it's just like in form of an ID number or um, basically just a permanent ID. So MAC actually stands for Media Access Control. So media access control address when you hear MAC addresses. So between your IP address and your MAC address, that is what helps networks understand where the data is coming from and how it's being transferred. So now that we covered those two, this is basically how you can look at it, right? So your IP address is the mailing address, as I stated. Your mailing address can change. You may move, right? So when you move, the IP address may change. So an IP address is changeable, whereas your MAC address is not changeable. So it's basically like the name of the person who is living in the home. Your name is not going to change, but your mailing address might. So a IP address is like the street. The MAC address is the person or the device that is using the street or lives on the street, basically. So now that we've covered that point, And understanding devices, understanding the different types of networks, what the networks is, and briefly how your data is sent. Um, we are going to look at how your home network works. So, when you use your home network, the very first thing you do is, you reach out to your internet service provider and you're like, hey, I need internet. And you buy an internet package, and it typically tells you what you're getting in your internet package, right? So you get home, you plug up your modem or your router, or if you have the combos, because they have those, then you plug them up and you wait for it to start. And you connect it through your cables, and you're basically waiting for that modem to get signals from the router to basically request some sort of connection, which is basically creating your home network. So once you have that set up, you then connect your devices to your router, and you're basically like, hey, I need internet, right? So once your router registers that you've connected your devices via wired or wireless, then the router is basically going to give an IP address to whatever that point is, the device, and it's going to tell the data traffic from the device to the internet where it needs to go. So when you connect it and you're like, hey, I need to go here, your router is going to figure out how to get you there via the internet. So basically, real briefly, that's how your internet works in a sense. So when you guys are using your network at home, you may have various troubles over time. So you may get that no internet connection portion. So sometimes this can be because of an issue with your modem or your router, and you just may need to restart it or update it. Or it could be an issue with your actual internet service provider. So maybe their system went down and they can't deliver access to the internet for you at the moment. Or maybe you forgot to pay your bill. One of those. So that is a common one, but these are some tips you can use for that. And then if you have slow Wi-Fi, so remember earlier I said the more devices you have, sometimes the slower your Wi-Fi can run because they're all fighting for space to use the internet. So to do this, maybe remove some devices. If you are, let's say, you have a two-story home and your internet box is on the first floor and you're on the second floor, that could be the issue sometimes. Just depends on your home setup. Or how far away from the box you are. So that would be something as well. So that's why if you go into the store and you see Wi-Fi extenders and things of that nature, that's basically for people who have a big home and need their Wi-Fi to stretch or at least carry their signal strongly throughout the house. So that would be a case for that. But of course, you've all probably heard of cyber attacks, and most of the time that is through the internet. So, networks are basically targets for cyber attacks. So, we have various network threats that can happen through the network. So, your hackers will generally try to access some sort of network and get access to data on the network or access to the device on the network. And some examples of some threats would be like your malware or phishing attacks or DDoS attacks. An example of this would be, a year or two ago, the casinos in Vegas were actually hacked. So people couldn't access their rooms at certain casino resorts. There were messages on the gambling machines, things of that nature. So the hackers were able to get into the network and cause destruction on these companies. So, of course, um, cyber attacks are very common these days, and unfortunately, as technology evolves, that it will continue to essentially get worse, especially with AI now. So, you just have to be aware that there's always threats to your network at all times. So, overall, you want to keep your network protected, and that means making sure you have secure things in place. So this would include your passwords and firewalls and encryption. Now, most people do not have firewalls in place. Companies typically have firewalls in place, but your normal home may not necessarily have a firewall in place. Can you set one up? Yes. Is it common? No, but you can do it. For most homes, all they really have in store is a password protection, and as we all know, your passwords are not necessarily the greatest passwords unless you are one who is very scared about getting hacked. Then, for most people, they put something simple as their dog's name, 1234, or something they can find publicly on the internet about them. So keep this in mind when you're setting any sorts of passwords, not necessarily only for your networks, but in all cases. You always want to make it as complex as you can. So, just by making your password a phrase you would know. For example, I love popcorn 28 or something like that instead of saying popcorn 28. That would be an example. And you can also have encryption in place. So encryption is just scrambling up the data, basically making it harder for people to understand. So basically, your data is scrambled until it gets to its destination point, and then it is unscrambled. So you technically do not see the data scrambling, but that's what happens in the background. So these are your basic security types for your networks. So, another keyword, security. Security is another keyword. All right. So, we basically made it through the fundamentals of networks, what they are, how they're built, the types of them, even how the data can go across the network briefly, and then what you need to do to protect it. So just remember that your networks allow you to communicate and send data with other technology devices, hence the internet and PANs and LANs and WANs. So keep those in mind. And of course, because your devices are connected and your devices have data, you always want to make sure at all times that you protect your networks from attacks to protect yourself from data breaches as well. So, overall, like I said, this is a very brief intro to networking. Again, networking can literally take months to learn and understand. So, yes, there is a lot of information missing between this, but I'm just sharing the main parts of networking that you need to know to just understand or get a general idea of how technology works. So, we will go deeper into data and networking in the next video. So, I will see you all then.